if we have such data, we can build a model and then identify whoever patient who is going to fall sick in the next 30 days, and advanced care can be taken. Okay. I told you these are all tabular data sets. So again, I have a question for you. What are the state of the art ML models for tabular data sets? Should we use LLMs? Is LLMs good for tabular data sets, or is there any other models required? And how are we going to give explanations to these things? First, we'll go into the first two questions. So first of all, given a tabular data set, how are we going to solve that problem? What are the first steps? Let me hear answers from you.
Sir, I feel if you have tabular data system,
Mm.
networking should be fine by
Which
giving
one?
which networking should be
Networking.
okay to predict the answer. Maybe basic
Uh,
ML would be good enough
Basic
to.
ML, yeah, good. Basic ML is good. When compared to LLMs, basic ML is good. Again, within ML, which one?
Right now, I do not have.
Oh, okay. I don't mean to.
Ticket.
This is not a question pointed at you. I'm talking to general audience. So just give a think. Just at least go through all the machine learning algorithms that we have. Which one is the best? So the moment if you give any tabular data set, there is a unique answer for that. That's why I asked this question. So first, in future, if you encounter any tabular data set, also first think along those lines. Start from that model. If that model, it will be like almost like a baseline for you. They are called boosting models. XGBoost, all the family of boosting models. They are the best models for tabular data sets. Even though in the age of LLMs, still people are using models like XGBoost, all boosting class of algorithms. Okay, and then my next question is how to give explanations to these models. So these models are only good at giving predictions. So even now I am telling you many use cases. In all these use cases, only it will give you a prediction of based on the past data. It knows that something can happen. Based on that, it will give you some prediction. But not just prediction is enough. No, it should give some explanation. Yes, because I weighted this factor this much, I weighted this factor this much. So that helps doctors or the people involved in it to take a more accurate decision. Just giving out a prediction is almost like a robotic thing, right? So which models will help us to give explanations?
Deep learning should do the job. Yeah.
Deep learning, you mean to say ChatGPT's explanations?
Yes.
Okay, if you are using Gen AI models, okay, to some extent they are giving explanations, I agree. But when it comes to these prediction type of algorithms, so for example, apart from ChatGPT, there is another type of models called BERT-like models, where you will get only a prediction, not a generation type models. So in that model, say they will simply predict a number. Say for example, now I am telling whether a patient should be discharged from the ICU or not. It will, if you use a model, it will only give you a number, say 0.36, 0.68, that's it. So the edge cases, the boundary cases will be very difficult to distinguish, say 0.48. Whether the doctor should take the decision to go ahead or not. So they will be complicated. Even in such cases also, we should be able to give explanations. Okay, I didn't write the answers in my slides. I will type it here. They are called Sharp and Lime, two popular explainers. So what this do is, even though they are model agnostic, with given any model, they will give you, if you have different, say 10 features, for each feature it will give some weightage. Based on this weightage, I am able to take this decision. Now the doctors can immediately, that is a very valuable insight. And my third question is, are there any models that provide both prediction and explanation together? So in the previous approach that I told you, XGBoost with Sharp, that's a good combination only. But then you have to train with two different models and you have to maintain two different models. So instead of that, if there is one model which provides both the prediction and explanation, they are called actually glass box models. Glass box means the other ones are black box models. The other boosting algorithms are black box models. XGBoost is a black box. It's a black box model. These glass box models, what they do is they will give you prediction, but along with prediction, they will also give the explanation simultaneously. Any glass box model will work. Okay, so given any tabular data set, you take along these lines. These will be your baselines, and if you want to improve, you have to beat these baselines. They are currently doing better, and they are even better than LLMs. Okay, let me go into another set of use cases that are used in healthcare, which are most widely used. They are called NLP use cases, natural language processing, how it is used in uh, healthcare domain, and what changes it has brought about. Okay. When solving an NLP problem, natural language problem, because of the natural language nuances that are present, gives many challenges. We will look at some of those challenges and what solutions healthcare domain, how they are typically addressed in a healthcare domain. So one of them is ambiguity. So words can have multiple meanings depending on the context, and we have to resolve them. And then context, understanding the nuances in the language. So, for example, if you see some disease in a medical chart, whether the disease is a present condition or a past condition, that context is very important. And then variability. So, the words kidney and renal actually mean the same, but then you can express the same idea in different ways. And then the semantic syntax and semantics of the natural language also poses another challenge. So, we need to address all these challenges. These challenges are common across any NLP problem in any domain, not just in healthcare. So how we handle them? So ambiguity and variability. So given a word, it can have multiple meanings.
Sir,
Yeah,
I have a question. But
yeah, please.
while building itself, if you justify and give proper predictability criteria, will it not be able to predict the right one itself? I mean to say, even appropriate word for that matter, so that there won't be any ambiguity.
Uh, yes, but there will be millions and millions of records.
Okay, complexity becomes a difficulty.
Yes, manually doing it is bigger. For example, I will tell you there is one terminology which people have attempted that. Your idea, people have actually thought and people have attempted. And even before this knowledge based system, even before machine learning and deep learning came in healthcare domain, people solved that problem. How they did is they leveraged a large group of experts and then they created medical knowledge bases to solve this issue. I will come to that. Actually, yeah, I will tell you how similar lies as what you thought, but they did it at a massive scale. Many experts were involved in that. And then they released that knowledge base publicly for use, just for social good. Okay. Uh,
Okay, thank you, sir.
Ambiguity and variability can be addressed by standardizing the terminology. So, for example, renal failure and kidney failure are synonyms. So, why don't we simply make both of them the same? If we solve that, there's no variability issue is solved. And depending on the context of usage, we can give a different ID to each of those words. If they are having the same words, we can give it the same ID. So, it will help us solve many issues. So, take an example. So, in this below sentences, note the word is shock. The patient is given electrical shock. So, here electrical shock is used in a positive sentiment. The patient is suffering from psychological shock after the accident. So, here psychological shock is a negative thing. Even though both of them are shocks, the context will change a lot and you need to distinguish both of them. So, just syntax matching won't work. Context also needs to be taken. What I observe, I have worked with some other domains also. When compared to other domains, this healthcare domain had one advantage. This standardization problem can be addressed using knowledge bases. What happened is people have built up knowledge bases of what are the terms that can encounter in medical domain. They have taken a list of all those, and over the years, and even now it is evolving. They take up all these knowledge bases. They release once a year. There are some knowledge bases which will release once in 2 months. So with every new knowledge coming in, they are still maintaining that knowledge bases. By using those knowledge bases, if you can first remove many, if you standardize the chart, if you standardize a medical report or any document in medical domain, many of these issues will solve automatically. These advantages I didn't see in other domains. There are attempts, like for example, they will use Google Knowledge Graph, or there are some publicly available knowledge graphs also. Using them, you can solve it to some extent, but in healthcare domain, They are thoroughly maintained and they make regular updates, and they are given by, there is an expert team which validates them. Even though they have errors, but still they are good enough to start with. This knowledge based approach is one, but there are certain things which cannot be solved using these knowledge bases alone. For understanding, for context understanding and semantics, we require deep learning approaches. Okay, before I explain how these all solved, some terminology would help a lot. There are two terms that we frequently encounter, which is called healthcare provider and healthcare payer. So healthcare provider means one who provides services to the patients. So they can be hospitals, clinics, and pharmacies. Healthcare payers, these are the organizations which are responsible for financing healthcare services. So once a patient goes, nowadays it's healthcare insurance is the typical way, because the costs have become very costly, so people are all going for insurances. So once the insurance is available, the person who is paying this is called healthcare payers. Insurance companies an example. There are certain government programs also, this Medicare and Medicaid. These are US healthcare programs. So what happens is, if you are an US citizen and if you pay tax for so many years, I think 10 or 20 years, you are eligible for those government programs, and government will take care of your health. So these are called payers, providers and payers. Okay. I will tell you all these things using an example called medical coding. This medical coding is one place where standardizing clinical information will be the first step. Even in other problems also, we can standardize clinical information. So it is actually a bridge between providers and payers. So what you would also have encountered people who are medical coders and all. So what the people, why this medical coding is essential is, once you get some service, if you want to get paid for that service, they require something called medical codes available. So if you go to a doctor and get treatment, they will only give what type of diseases they diagnosed, say for example diabetes mellitus or heart failure, something, or renal issues, like that. They will give you only what treatment you, what diseases you have and what procedures they have done. But when you goes to reimbursement, you need to code it appropriately and then submit it. Only based on the codes, reimbursement will be done. And also, to interpret clinical decision support, we require to interpret test results without any ambiguity. Say for example, a particular test has been done, using which instrument he has done, and what are the units of measurement. All these things, there are certain nuances, and based on that, a doctor can, professionals should be able to make an unambiguous interpretation of that. So for all this, if you standardize that thing, the decision support will become very effective. And also, if you standardize that, you can track what is the health of a population group. Based on that, government can plan for vaccinations and also medication safety, and whatever drug these generics, the pharmacy companies may not give the actual drug, they may go for some cheaper drug. To avoid all these issues, if you have an accurate code, we can say which drug has been given. To avoid all these things, we require some standard terminology. So this is how the whole thing is connected. These healthcare providers will be giving the information required for medical coding, and once the medical coders receive this information, whatever they do, their output is consumed by various peoples, like healthcare payers will consume that information. It is used in clinical decision support, for health monitoring by government agencies, for medication safety. All these things are dependent on medical coding. So even though the doctors gives the treatment and their medical reports, after you standardize only, things can help. They can actually people can use it. For that process, medical coding will be the bridge between these providers and payers. Okay. So in order to do this medical coding, there are various types of thesaurus have come up. So if you take up, because these thesaurus are more or less freely available and any person can download them. So these thesaurus will be like helps to standardize a thing before proceeding further. Say, for example, LOINC. This is one terminology where it standardizes laboratory tests, vital signs. So so if you do a laboratory test with a particular instrument, they will have one code. If you take it some other instrument, you will have another code. Or based on the units, the code will change. But the codes are standardized. Similarly, for medications, so every medication can have drug ingredients will be there. What is the strength of the drug? So whether the dosage forms, whether they can be taken along, is it in a syrup form, or is it in a tablet form, or is it an injection form? So based on all these factors combined, there is a database available called RxNorm. Another database is SNOMED CT. This is a clinical terminology system used for coding diseases, conditions, so different medical states, what are the procedures. So this is essentially helpful to code a medical record. Whatever the things that you frequently encounter in a medical record, to code them in a uniform way, we have something called SNOMED CT. Okay. And for billing purposes, these are general thesaurus. They are for billing purposes. If you want to submit it to a medical insurance company and get paid, you need to use only some thesaurus have been developed exclusively for that. One of them is ICD. For classify, it contains codes for all the diseases and health related issues. HCC is a subset of ICD and is primarily developed for Medicare people. Medicare, that is the US government policy. It's they have their own risk adjustment model. In risk adjustment model means so your next issue. Okay. In the next year premium will be dependent on the patient's condition. Not just every person needs to pay the same premium, right? So it all depends on the health of the patient. For that, they have come up with a model called a risk adjustment model. That is comes under HCC. And then there is other terminology called CPT. So it contains codes for medical procedures and services. So in the past two slides, I have given you nearly some 6 terminologies, and actually there are 200 plus vocabularies are there. So if these many number of vocabularies are present, we can easily see that from one vocabulary to other vocabularies, there will be definitely be intersections. Okay, for example, SNOMED CT overlaps with ICD, SNOMED CT overlaps with CPT. So when we have such huge different vocabularies, it will be difficult to manage. So there is something called there is an organization called National Library of Medicine in US. What they came up with an idea is, why don't we integrate all the medical information from all these vocabularies so that we will have one unified knowledge base. From that unified knowledge base, we will be able to do a crosswalk to any other vocabulary. So that is the idea they came up with. And they integrate concepts nearly from 200 different source vocabularies. So whatever vocabularies that I mentioned to you, they will can be all be covered under this we call it as a meta thesaurus. It is a thesaurus of all the thesaurus. So they came up with this idea, and every year, twice a year, they make releases with all the advancements. So for example, before COVID came up, we don't have any codes for COVID. So after COVID came up, they came up with new codes, and they immediately added it to them and released them. Here, how this vocabulary looks like. By the way, this is free. Anybody who can register and they can download, and we can freely integrate into our applications. What they have is they have same concept for different terms. Say for example, heart attack and myocardial infarction. They both are two different syntactically different terms, but they both have the same ID. Similarly, kidney failure and renal failure. I will give you an example. Say for example, Addison's disease. Say in SNOMED CT, it has one ID. Say starting with 363, and it is called Addison's disease. In Medline Plus, it has another ID. But if you go to Mesh, you can see that apostrophe S is dropped. They simply call this as Addison disease. And a variation of SNOMED, they call it as bronze disease. Okay. And if there is something called primary adrenal insufficiency, and if you have something called Addison disease, Mesh gave them the same ID to mean that they both are the same. So essentially, even though these terminologies are all different, uh, they have a different IDs in each of them. What UMLS came up is they have introduced their own ID, their own concept for that. But this concept is mapped to all of these IDs. So once if you given a term, if you can identify a UMLS ID for that, from that you can find out what is the equivalent code in every other terminology. So that is the beauty of this. Okay. So once this knowledge base is available, so that alone is not enough to solve the problem. We require to develop either go with a rule-based systems or a deep learning based systems. So as I explained, the rule-based systems are still in prevalence because of these knowledge bases are available. We can create rules on tops of these knowledge bases. Uh, uh, but they require extensive expert knowledge. Luckily, in healthcare domain, it is available, and there are many volunteers who freely contribute to UMLS. They make advancements and release them every year. So these systems are still in use. When it comes to learning based approaches, currently the systems that are used are transformers based models. So you might have all heard. So what is the paper that first introduced this transformer based approach? What is the title of that paper? Anybody? Sorry. So what is the title of the paper which first introduced the transformers? Yeah, please speak up. Or is it so boring? I'm dumping more information.
Maybe I might have missed it. Not sure.
Okay. Okay, it's attention all is all you need paper. Uh, it is the first paper which introduced the attention mechanism. So given any piece of text, how one word can focus on the other parts of the word. So this is the paper that first introduced transformer models. Actually, that paved way for today's chat GPT. There are two famous models that came up as in part of deep learning models that utilizes the transformer models. One is BERT and then GPT. The big advantage of that is long range dependencies. Even if you give a long text also, we are able to capture dependencies in them. Okay. Another major advancement that happened is pre-trained models. These models are trained on massive text corpora. Almost everything present which is publicly available in the internet on all the texts, these models have been trained. And nowadays we see in newspapers some copyright issues also because of that. Now I think going further, people will once you write an article, we should also somehow safeguard it from LLMs or some copyright policies needs to come up. Now that is one of the debates that is going on currently. You can see it in newspapers also. But almost they are trained on massive text corpora. And two types of models have came up, as I told you. One is GPT models, which is used for generating text. That is what our chat GPT is. Underlyingly, there is a GPT model behind that. And then BERT is majorly used for prediction, not just for generation. Prediction problems can also be solved using generation, but there are some tasks which BERT is still good at. But when it comes to a specific domain, say for example, a healthcare domain, we have some domain specific models. Say for example, BioBert is there, clinical BERT is there. What these people have done is they have taken up the BERT models generally available, and then on top of that they have introduced they have further trained them using the medical knowledge relevant, and they came up with these clinical models. Okay. Here are some of the questions for you. What are the pre-training tasks used in BERT and what are the pre-training tasks used in GPT? So these are the general tasks, and now what we do is fine tuning on top of them. But when it comes to pre-training, they solved it using a particular problem. So when I first learned them, I was very surprised to find that what if you solve using those problems alone, you will be able to capture all the knowledge, all the essential knowledge that is required, and everything is stored in the model weights. First, I was very amused. What are those tasks? So for BERT, the tasks that are used are masked language modeling. I don't know why I'm unable to type. Sorry, I'm unable to type. Okay.
In the chat
Uh,
box.
yeah. No issues. I'm unable to type. Okay, no issues.
Okay.
Ah, okay. Masked language modeling and next sentence prediction. So they take up a large sentence and then they mask it some parts of it and then they send it through transformer blocks and towards the end they are predicting what is that missing word. This is called masked language modeling. That helped BERT, and also BERT is also pre-trained with something called a next sentence prediction. And for GPT, it is even very simpler. They simply train with what is the next word prediction. So you take a big sentence and you divide it, take one word after the other. Given any 3 words, what is the next word? Given 4 words, what is the next word? Given 5 words, what is the next word? This is what is called a language modeling problem. And that simple training mechanism on a huge text corpora is what helped bring a game changer idea of ChatGPT today. So the problem is very simple. The training idea is also very simple. Take a large text corpora, train it only for what is the next word. That's it. And now our systems are also work like that. They only know how to predict next word at a time. That is why if you type in chat GPT also, it will not give you all the answer at once. It will give you word after word. And because of the streaming happening over the network, you will see one word after the other word coming. It's a very simple idea. While prediction also, it works the same way. Okay. The core idea why this chat GPT and all these systems are working is they are able to transfer knowledge from one domain to another domain. Even though they trained it on some other domain, the reasoning process that is present in different domains is almost the same. Because of that, even though it is trained in one domain on some tasks, we are able to apply it very easily to use it in another domain also. Other way of extracting is some examples of is given any medical text, if you ask ChatGPT to, if you give a proper prompt, if you want to do information extraction, we are able to do it. So one of the benefits that I want to tell you is it reduces the need for large labeled data sets. Previously, even though deep learning has been in existence before this before transfer learning idea came into existence, creation of data sets is a huge problem. We are not a may all everyone can afford to keep manual annotators and label that. So once these large label data sets are available, the now things have become a different game has started. Now people simply use prompts and then they tune it for their specific domain. Now with very less amount of training data, people are able to come up with good ML models. All this is made possible because of these pre-trained models available and the idea of transfer domain. Because we are able to fine tune them, all these changes have brought up a revolutionary change. Okay. Even though what is the state of the art in medical coding? Yes, no doubt. With the advancement of AI and ML technologies, medical coding automation has made a substantial progress. Uh, when it comes to coding accuracy, I am a bit generic here. It all depends on which coding you are doing. But in general, if you take that, if previously manual coding have an accuracy of 80%, with AI systems, it got up to 95%. There is good improvement in that. But there are some limitations to that also. It excels at handling routine tasks, but there are cases, complex cases, where we require human coders and human doctors or some medical experts to involve in it and take a decision. So the future of medical coding, it will be a collaborative approach with the AI and human coders, with AI doing some repetitive tasks and human coders doing quality control and auditing. So the future will be like where both medical human experts and AI systems both will work in collaboration. Okay, I will go to the final module of my talk. So I want to talk about security and ethical considerations. So we have seen examples of NLP use cases and vision use cases. In all of them, there are certain security principles that should be followed, and there are certain ethical guidelines that should be taken into consideration. We will go into them. What are the different challenges? So just like, because healthcare domain is some sensitive domain, so what are the different challenges present in security and ethical considerations? We will go into them. Particularly, I will talk about data privacy and security. We'll also talk about bias and fairness. So data privacy and security. So why security is important? A lot of sensitive patient data, such as personal information and medical history. If a doctor has given a medical report, it will all have the person's all the past medical history, its personal habits, what are his habits he has undergo, and these data you just cannot make it public, and you cannot just directly use it for training. If you just use it for training, suppose imagine a case where a patient's personal information is used for training a ChatGPT like system. In future, if you prompt it and if it gives the exact name, it will be very difficult, right? The person can sue the particular organization. It's a violation of personal privacy. It's including into his personal life. So in order to do that, there are certain standards called HIPAA standards that has to be followed. What they do is the data should be protected. They should be used, the medical information should be used, but the data should be protected. And also certain security protocols should be followed. Say, for example, if I get the data of, say, a million charts of the patients, and if I store within my database, if some data breach happened, and if all that information goes out, it is a data breach. There is a leakage of private public. It's a leakage of personal information. So I need to take importance of all these measures and implement proper security principles in place. So what are the ways to protect data? If you are transmitting it from one place to another, yes, you need to encrypt the data. And after the data is encryption, towards the end, they should be decrypted. And once, who are the people? You all should also restrict the people who have access to the data. Access control mechanism should be brought into picture. Uh, Data anonymization should also be done. Like I told, what happens if a model is trained with personal information? You cannot do it. So whatever personal information, like the name of the patient, his location, his age, those things should be masked before further using. So data anonymization should be done, and also the data should be stored very securely from cyber attacks. So these security principles have to be kept in place, and also bias and fairness. Bias, say for example, you are trying to develop a system within India for all different groups of people. Suppose that, but the training data is only based on male population. Obviously it won't, if during working, it won't work for female population, right? So that is an example of gender bias. Or suppose if you create a training data belonging to only one ethnicity. So for example, if I take up only from a few states, say Tamil Nadu I have taken, I cannot go and implement that same solution in say northeast or in north. There will be differences, right? So if you want to develop a robust solution, you need to be free from any racial bias, and similarly age bias. So I cannot train only it on say younger population or older population. If you train it only on one thing, so it will not work for the other group. It will give you a very biased result. So it can lead to very unfair decisions. Trust issues will come up. So you need to ensure that proper fairness is maintained. So what are the different ways to ensure fairness? So once train the model on diverse data. Different age groups, genders, ethnicity, socio-economic groups even. And then once the model is deployed in production, you need to regularly audit the model to detect bias or any unfair decisions is going on. So in the past, few of them require manual sampling. In the past 100 decisions given by the model, how many of at least 10 can go to an audit, and the auditor can check which of the model is correct or not. And then transparency. So by giving the AI decision process clear to the stakeholders with proper explanations, the decision can be validated. Um, And also now, because of these Gen AI systems are in place, we require something called guardrails. So suppose if you ask something, it recently happened with one of the famous models, where the patient, where a person interacting with the system expressed some problems that he is facing. The model simply told him to go and commit suicide. Please go and commit suicide. So that's a very dangerous response that a model can give, right? So in order to do that, guardrails needs to be in place, so that whenever a response is generated by a model, before it is given to user, that result, that text, whatever the response that came up, should be validated to detect any harmful content, or is it causing any bias is involved within that, or is it giving some biased opinions, without giving. So these guardrails needs to be developed, and if you don't have proper guardrails, yes, the systems can produce some harmful content and can lead to many problems. Okay. So I'm most done with my talk. So I'll just give the conclusion. So yes, Stalin, you want to tell something? Okay.
No.
Okay. Yeah. So AI is revolutionizing healthcare. It is an ongoing effort. So we have seen examples of how to improve diagnosis and treatment, and how the costs have reduced. And to even to the underprivileged people, AI helped to reach healthcare. And also we require AI products needs to combine both rule-based systems and model-based system, because healthcare domain is a very sensitive domain, and you cannot just rely on model responses. So you need to have appropriate rule-based systems also in place. Also, while training the models, proper safeguarding measures should be done. So the personal information of the patients and all these should be protected. Models should also be trained to avoid bias and ensure fairness in the decisions. The future is expected of AI solutions in healthcare domain. It expected to be a collaboration between AI and humans, with AI handling repetitive tasks and expert humans focusing on the complex tasks. So these are some of the references. Also, I have given inline what are all the references. You can go through them. So thank you. So if you have any questions, please ask me.
Sir, question is regarding one of your remark that it gave or it said that commit a suicide.
Yes.
This should not be the case, at least in the case of AI that is used in the medical fields, because that can be sealed, or that is not even prediction of something. It says a suggestion in that regard with respect to some particular thing. If it's in a medical, doctor or some professional should be the ultimate decider, though these instruments give.
Yeah. Yes.
So, which is this physically a AI
Okay, that
tool
is
that we
actually a general chatbot. It is not specific. It is a general use chatbot like ChatGPT. Okay, it came up in the news. I read it in the news article only. The patient express. I think it's actually some graduate student who played a lot with that system, and he was eventually able to, using his prompting techniques, he was able to move it into bias, and then he published that bias. This system is not performing well, but it is not any medical decision making, but it's a general use chatbot.
But I have followed up question is whether this AI or the system can develop a feeling. How can it be? How can be the AI biased with the person?
Not a person, based on the conditions.
Okay, conditions, yes, sir. But is it possible that it takes a certain attitude?
It can take certain attitude. So if you don't keep proper guardrails in place, yes. See, depending on the symptoms, so it's all depends on what data it is trained on. Okay. So if it is trained on some, say, stories, we don't know if it is not when I say general models, these models are able to do both general tasks and also clinically relevant tasks also. So if it is in fiction, committing a suicide or killing, they are more prevalent. If it is trained on such data, there will be always at the next stage. If you look at what is the next stage, it will always have some probability with which what the next word is. And if you give appropriate prompts into misleading that, it can do that. That is why I told you the emphasis should be on having proper guardrails in place. There are certain systems which are available today. For example, Anthropic is very well known for its guardrails. It will never give you a harmful content. There are certain systems which are not still yet matured, and they are maturing. And with one such system, the user was able to trick that thing to give such a harmful content. By default, they won't give. That's why I was addressing the need that medical coder intervention is medical doctor's intervention is required before taking a decision.
Okay, thank you, sir. One more followed up question is which tool is best, or in other words, which can be used because in your specific field when it comes to computation or simulation or multi-level model learning, which tool is recommended from your side?
See, it all depends on the use case, right? Yeah, I need to go into more concrete use cases before I can tell you what is that. Okay, if it is a prediction problem, take any bird family of models. If it is a generation problems, again, it all depends on your budget also. How much effort how much money you are going to spend. Say, for example, now the models that are in place, generation models, some of them are very costly. Okay, you might have seen the recent OpenAI's models O1 and O3. They are very, very costly. We cannot even afford that. Okay, that the or if you want the proper guardrails in place, Anthropic is one good suggestion. So without knowing into the if you can tell me the accurate specifics, these are the general things. Whatever are generally used, all of them I mentioned in the stock. So depending on your use case, some of them will work.
My one of the course work is on Schrodinger actually. So will it be okay to go with it? Schrodinger tool.
Schrodinger, I have not much idea on that.
Okay, okay, no problem.
Yeah, I told you no, but these solutions are also costly. Using ChatGPT is also costly. It depends on how much tokens you want, what is the exact use case and all.
Okay, okay. Thank you, sir.
Am I audible? I have one question, actually very generic.
Yes,
Am I
Ganesh, please
audible?
go ahead.
Is there any specific ethical committee that every AI bot has to pass or has to before it is published?
Any ethical committee? Okay. See, before an AI bot is released, this is a very generic question. Okay, I will say that see the training data which is being used, whether if it is copyright protected or not, that comes the big question. Now, OpenAI in the past 3-4 days, if you look at the newspaper, there were many complaints against OpenAI. One of the news agency, ANI, filed a complaint in Supreme Court of India or Delhi High Court. At one of those places, they filed a complaint against OpenAI that they are using our data to train their model, and that is a violation of our creativity, and our content writers will get affected because of that. That is a case going on, and also. You last month one guy committed suicide who came out of OpenAI and who is a whistleblower of OpenAI. So these things, which data, whether the data that you write now, whether it should be allowed, that is also a famous discussion that is going on. Whether a new principles needs to come up or a new security measures needs to come up, whether a particular data should be used for training or not. Because if you are a content writer and if you, it can catch your style if it 4-5 articles, if you give it to it, sixth article it can write on itself. So that is a very serious violation of creativity of the people, right? So those government has not ensured those principles in place, but nowadays there is no such a guidelines, but that has to come up. Without that, the creative writing will be at a severe danger.
Okay, thank you. Thank you. Thank you.
Yeah, thanks, Ganesh.
Yeah, I think if there are no questions, then we can conclude the
Any more
meeting.
questions? Yeah.
Sir, go ahead. Yeah.
Yeah. Thanks, Dr. Dileep, for your nice talk on AI applications in the healthcare industry. So you gave a nice overview about the healthcare industry and what are the different AI tools and where and how it is applied and how this application is evolving. And you ended up with a nice ethical discussion also. So overall, we got many insights. So thanks a lot.
Yeah. Thank you,
Uh,
Dileep, for sparing your
Thank
time
you.
and sharing your knowledge here.
Okay, thank you, Nalin and Rajesh, for giving me this opportunity. I was able to interact with faculty members. Even I am a PhD holder, so I know what it means to be in faculty. People are expecting. So I hope some of the things that I have given will help you in either in your research, and you will be able to take it forward. Thanks for meeting all of you.
No, definitely. Thank you.
Participants,
I know
please
how
provide
busy
the
you are,
feedback.
and thanks for accepting the invitation here.
Yeah, thank you.
Participants, please provide feedback, and Dr. Dileep will share the participants' feedback to you. Okay.
Okay.
Once we resume.
Thank you, Nalin.
Thanks.
Bye-bye. Have
Bye.
a good day.
Yeah. So we
I
will
think,
have our
Yeah, next session is at 5 o'clock, right?
5 o'clock. Yeah.
Yeah, another 15 minutes is there. We'll break
15
for
minutes.
here.
Yes.
Yeah.
Thank you.